we provide you two convolution result. Okay, this is a 4. You can see that the xn, the convolution result between xn and hn. In this case, xn is have only 4 non-zero element. H it have 5 non-zero element. Therefore, we should fix h. Okay, and we will process x. Okay, because sorry that wait a minute. Okay. Okay, I just cut off the phonics. Okay, the xn and hn. Okay, we will fix the hn first, and we will process x. Okay, in this case, okay, the first one we process here. Okay, x here 2. Okay, 2. You can see that 2 multiply with 3 give you 6. Give you 6. Okay, 2 multiply with 3 give you 6. Give you 6. Multiply with 1 give you 2. Give you 2. Give you 2. Therefore, it has 5 impulse. The first 2 impulse, the first one is to have the 6 in magnitude. Second one is have 6 in magnitude. And 3, 4, and 5 is have 2 in magnitude. The location of them, due to xn is already at the position xn equal to 0. Therefore, the position of them will be identical to here. Okay, it's identical to hn directly. Okay, for the next one is okay xn. The second one is the blue one. Okay, the blue one is have the magnitudes of them equal to 2. Okay, equal to 2. 2 multiply 3 give you minus 6. Give you minus 6. Give you minus 2, and the minus 2. The location of them is not identical to the first one. It's the same as the green, but it shifts in the right hand side by 1 position due to the location of x of the blue one. Okay, here shift by 1. The next one, okay, the next one, 1 multiply with 3 by 1 of the x. Okay, the black impulse. The black impulse multiply with h. The result equal to 3, 3, 1, 1, 1. Okay, but the location of them will be the same as here. Okay, it will be the same as the green, but it shift in the right hand side by 2 position. 2, okay, 3, 3, and 1, 1, 1. The last one is equal to minus 1, the light blue. Minus 1. Minus 1 multiply 3 give you minus 3. Multiply 3 give you minus 3. Multiply 1 give you minus 1, and minus 1. Okay. Multiply 3, 3, 1, 1, 1. You sum them. Okay. The summation will be with its side. 1, 3, 6. Okay. This is only 6. The result equals to 6. This is the 6 and minus 6. The result equal to 0. Okay. Yeah. You can see that this 6 and here is a 5 give you minus 1 and so on. This is the overall result after you take this convolution. The next one determines the convolution of xn is here and hn. Okay, the same as here. Okay, here xn it have okay 4 non-zero. Hn we have 5 non-zero. Therefore we fix h again. We process x. Okay, here minus. Okay, the first impulse is the orange one. Okay, the orange. Okay, 2 minus 2. Sorry, minus 2 multiply 3 give you minus 6. Minus 6. Minus 2. Minus 2 and minus 2 is here. The location of them, the location of the result equal to identical to h. Okay, because the orange is in the center. It have no shifting. The next one is the blue. The blue is okay. The magnitude of the result is the same as the first case. Okay, minus 2 multiply 3 give you minus 6. Minus 6 give you minus 2, and the minus 2. But the location of them will be shift in the right hand side of the green by 1 position. Therefore, the first impulse give you at the 1 position. Minus 6, minus 6, minus 2, 2, and 2. Okay. The next one, the black one, 2 multiply with 3 give you 6, and give you here 6 and here, okay, and so on. Okay, the last one, the same. The last one, the right blue is the result. The impulse side will be the same as the black one, but it will be shifted in the right hand side of the green by 3 position. Okay, it give you 6 and 6 and 2 and 2. Oh, sorry, 2. Yes, and 2. You see, okay. You sum them, the result will be here. Okay. If you do by yourself, you can see that, okay, the way to take the convolution in the discrete domain is more easier than continuous domain. It have no integration, but you must take the summation in each step. Okay. Next one. Okay, now the last 2 topics, okay? The different equations model and the term in the natural response. Traditionally, the discrete time LTI system are modeled by the linear difference equation with the constant coefficient. The first order linear difference equation will be modeled by here. The different equation is different from the differential equation. Okay, here yt instead it will be in the function of its derivative. No, in the discrete domain it will be in the time shifting version of them and in the xn, where a and b is a constant and x it is input, y is the system output. The n order linear difference equation will be you shift yn by n in here. We call them n order. Okay, x is the same. You can shift them by many order. Okay, but the order of the different equation depend on the maximum shifting in y. The solution of the different equation in this case, the way to solve them. In this section, we present the method for determining the solution of the different equation in this general form. The way to solve them is close similarly to the differential equation. The general solution of the yn can be expressed as the sum of the complementary function yc and the particular solution yp. The complementary functions yc can be determined from the homogeneous equation. The homogeneous equation you can determine from the general form of the differential equation by you set non-y term to be 0. Any term that don't have y, you set them to be 0. Yeah. And the solution of them is yc, or the complementary function will be in the term of c1 z1 power n plus c2 z2 power n and so on. Okay, depend on how many order you have. If we have 1 order, you have only 1 term. If you have 2 order, you have 2 term. If you have 3rd order or 3 order, you have 3 term. If you have n order, you have n term, cn. The unknown coefficients Ci, such as C1, C2 to the Cn, can be determined by using the initial condition. The next one, the particular functions Yp or the force response can be determined from the weight sum of the mathematical form of the Xn and its delay excitation that are different in the form of Xn. Yes, sorry. Yeah, in the form of such as if xn equal to 5 constantly, okay, yn equal to constant, okay, 5 is constant to all, right? Even though you're shifting them, it is still the same, okay. 3n, okay, is equal to the term of 3n plus with the constant, okay. If it have 3n power 3 plus so on, okay, it derivative of them, okay, or the time shifting, okay, in the general form of them is will be p1 n power 3 plus p2 n power 2 or n square plus p3 n plus p4. Okay, if we have the constant okay, in the power series, okay, is 5 plus 0.2 power n, it will be the same form, 0.2 power n multiplied with the constant p. And p1, p2 of p can be determined from when you substitute this particular function into the differential equation. If it have the function of the cos, it will be in the term of the cos and in the term of the sine. Such that if the input is 2 cos 3n, okay, the particular solution or the particular function will be in the cos 3n and sine 3n with the difference constant. Okay. Now if we have n cos 3n, n cos 3n, okay, the form will be a little bit more complicated. Okay, it will be in the form of n cos 3n and n sine 3n. Includes cos 3n and sine 3n. The unknowns coefficient pi such as p1, p2 to the pn of the force functions can be determined by substituting yp in the different equation. Determine the solution of the functions of this, okay? Determine the solution of the following different equation here. Okay, in this case, you're checking that, okay, how many order of them depend on the maximum shifting version of y. In this case, we will have only one, okay, therefore it's the first order. The general solution of the yn can be expressed as the sum of the complementary functions yc and particular solutions yp. The complementary functions yp, yc, or the natural response you can determine from the homogeneous equation, or you set the different equation and you kill non-y term. In this case, the first term is have the y, is okay, is still y term. The second term is still in the y term, but this term is un, right? Un is non-y term. If it's non-y term, set them to be 0. Therefore, the different equation will be here. After that, you can determine the characteristics equation. Okay. If what about the characteristic equation? Okay, use checking from the maximum shifting first. The maximum shifting have the power 0. Okay, set power 0. Anything power 0 give you 1. Okay. This thing will be, the power of them will be increment by 1 each step. Okay. Yn is here. It will be set power 1. Okay, set power 1 give you set. Therefore, the characteristics equation will be provide you set minus 0.4, sorry, set minus 0.6 equal to 0. Therefore, set equal to 0.6. Therefore, in this case, you can determine the complementary functions yc equal to c1 set minus set 1 power n, and set 1 in this case equal to 0.6 power n. Now, the next step, after you determine the complementary function, next step you must determine the particular solution from non-y term. You check for non-y term, okay? The particular solution yp or the fourth response can be determined from the weight sum of the mathematical form of xn and its delay excitation that are different in the form of xn. Yeah, it's 4. It's constant, right? It's 4. Therefore, in this case, it's a 4un, or for time greater than 0 is equal to 4 or constant. Okay, you set them to be the constant p. Okay, the unknown coefficients pi of the force functions can be determined by substituting yp into the difference equation. Okay, you substitute, okay, yp to be constant. Okay, substitute constant in here. Yp is constant. If you shift them, the constant you shift the function in the right hand side or in the left hand side is still identical. It's still the same p. You substitute yn minus 1 with the p again. Okay. Therefore, the difference equation that you get after you substitute, okay, the particular solution into them, you get p minus 0.6p equal to 4. Give you here 0.4. You get p equal to 10. Okay, p equal to 10 is mean the particular solution give you 10. The general solution of yn can be expressed as the sum of the complementary function yc and particular solutions yp is here. The complementary, okay, and the particular is 10 is here. Now in this case, C1 is still unknown in your general solution. You can determine C1 by you use this initial condition. The initial condition is give you y0 equal to 0. The unknown coefficient C1 or Ci's can be determined by using the initial condition. And you use, okay, y0 equal to 0. Substitute every n to be 0. give you 0 here. Anything power 0 give you 1. Therefore, you get C1 equal to 10, C equal to minus 10. You substitute them back, give you here yn equal to minus 10, 0.6 power n plus 10 un. Yeah. Now, the next one, after you know that, okay, about the different equation, the response of them, yp and the yc. The next step, you must try to relate between the mathematical equation and the physics world. This section describes the general solution of the difference equation model to the response of the physical model. If the system that you have is here, represented by this different equation. If you feed inputs x, okay, output will be in the term of the complementary function and particular solution. Yc came from is so-called the natural response or the unforced response or the zero input response or the transient response that is depend only on the structure of the system itself. The function set I power n in the natural response is called the mode of the system. And this thing is used to control the system is stable or not. Okay, stable or not. Yp is the forced response or the zero state response or the steady state response. Is depend only on the both system structure and the input or excitation. Okay, Yp is depend on, if you feed unit step in here, Yp will be in the form of the unit step and when past the input. Okay, or if you feed the sinusoidal into them, okay, the output Yp will be in the term of the sinusoidal, maybe attenuate or maybe amplified by the system characteristic. Yeah. Okay, next one. The term in the natural response. We concentrate on the complementary function or the natural response. This section describes the YC or the natural response or the unforced response or zero input response or the transient response is dependent only on the structure of the system. The mathematical form of the natural response is determined by the root of the characteristic equation from the homogeneous equation. Okay, you know that, okay? YC you can determine from this different equation from the homogeneous equation by set non-y term to be 0, and you can determine the characteristic equation and you can solve them. Okay, if it have n order, you have, okay, n0, n1, n2, n3 to ni. Okay, this characteristic equation and you can get here. The general solution will be, if it have n term, you have set 1, set 2, set 3 to set n. The key is the value of the set in this case. The factor set I in the natural response is YC is called the mode of the system. The section describes the different form of the system mode or set I that can appear in the natural response. If set I is real, then the natural response will be in the exponential form. For example, if set I is greater than 1, then the natural response, okay, if set I is such that, if set I equal to 2, equal to 1/5, equal to 3, you can see that the complementary function, okay, or the natural response will be increasing when n increasing, okay, unbound, okay, in the exponential form. If set I equal to 1, okay, it will be constantly, equal to 1 constantly, okay. If it between 0 and 1, the natural response YC is decaying in the natural response, okay, when n increase, okay, YC will be decreased and reach to 0 soon, okay. Next one, okay, if set I is negative, if it's between 0 and -1, will be decaying, but the magnitudes of them will be positive, negative, okay, it will be alternately changed, okay. And if we go to -1, okay, the magnitudes of them is still 1, but, okay, the size of them will be vary from n, okay. And the last one, if the set I will be greater than is less than -1, then the natural response YC will be increasing in the exponential form, okay, increasing in the exponential. Next one, set I is a complex. Then if it's a complex number, okay, depend on the real part of them. If the real part is greater than 1, okay, it is complex, it will be oscillate in the sinusoidal waveform. But if the real part of them will be greater than 1, the overall envelope of them will be increasing in the exponential manner. If the real part is equal to 0, it will be perfect sinusoidal waveform, okay, oscillating, and the magnitudes of them is constant. And the last one, if the real part of them will be less than -1, if it's less than -1 or less than 1, okay, the magnitudes of them will be decreasing, but it still oscillates, okay, it still oscillates. This is all characteristic of the natural response that you can find from the real system is, okay. Therefore, the response of them depend on Zi, or the root of the characteristic equation, or the magnitudes of our root of the characteristic equation is less than unity. Okay. Then the natural response YC is a bound or is stable. Okay. The magnitudes of the root of the system characteristic equation that are lie in the unit circle or the set plane is necessary and the sufficient condition for the causal DT-LTI system to be stable. It means if the magnitudes of Zi that you saw in this step is less than 1, absolute of them is less than 1, is stable. Okay. You can check that, okay? Determine the natural response of the following differentiation equation and determine whether the system is stable or not, okay? You can check that by this system, okay? Now, you can, in order to determine the natural response, you must determine the homogeneous equation first. Set the homogeneous equation from the general differential equation form by set non-y term to be 0. In this case, you set x to be 0. You get this, okay? This thing is the homogeneous equation. You can get the characteristic equation, okay? And you can factorize them. You get 2z, okay? Z1 equal to 0.75 and 0.5. Both of them is less than 1, right? The magnitudes of them is less than 1. Therefore, in this case, the system is stable because both root of the characteristic equation are lie in the unit circle of the set plane. It equal to 0.75 and 0.5. Next one is, yeah, the next example is here, okay, is provide you the different equation and ask you to determine the natural response of the following differential equation and determine whether the system is stable or not. Okay, checking that. Okay, from the different equation, you set non-y term to be 0, you set x to be 0, and you factorize them, you get this, and you can determine the the characteristic equation. Okay, the characteristic equation get here, you factorize them, and you can determine Z. Z in this case, it have two values. One equal to 0.5, another one equal to 2. You can see that due to one of them is greater than this, okay, the term of 2 is greater than 1, right? The magnitudes of them is greater than 1. Therefore, the system is unstable. The system is unstable because one root is located at +2, a lie outside the unit circle in the set plane. Okay. It's your turn. Hello? Do you can see the slide?
Yes.
Okay, capture this and let's do it, okay? I will sharing the slide in 1 minute quickly. 5, 4, 3, 2, 1. Okay. I will give you 20 minutes and I will provide your solution and we will continue to give you another one. Okay. Yeah, I will go to drink 1 minute. Okay. Okay, I'm back. Okay, if you have any question, you can talk to me or you can ask me. I give you another 15 minutes, okay, and I will provide your solution. Hello, can you hear me? My internet problem a little bit.
Yes ค่ะ
Okay. If you already, hello, can you hear me?
Yes, sir.
Okay, if you already finished this, you can do the next question. Okay, for this question, okay, I will provide you. Yep. Can you see in the I will show in the slide. The second question, can you see the slide? Okay, capture is okay, and I will provide your solutions in another 20 minutes, but in another 5 minutes, I will provide the first solution. Okay, quickly, let's do it. Capture the second question in 5 seconds. 4, 3, 2, 1. Okay, I will give you completely solution in 5 minutes. Hello, can you hear me?
yes ค่ะอาจารย์
Okay, I will provide the first solution. Okay, this question will be provide you consider the system with the input and output related by this different equation. Okay, this is the second order. Okay, the maximum shifting of y is 2, therefore the second order. The initial condition provide you two initial condition to determine two constant. Okay, determine the natural response, determine whether the system is stable or not, and the determine is the force response of the particular function yp when the input equal to constant yxn equal to 3 Newton. Okay, and determine the general solution. Okay, the first step, determine the natural response yc of this system. Okay, the complementary functions of the yc or the natural response can be determined from homogeneous equation. And this equation, the homogeneous equation, is mean you kill non-y term. Okay, non-y term is x in this case. Therefore, you get yn plus 3, yn minus 1 plus 2, yn minus 2. The characteristic equation is z power 2 plus 3z plus 2 equal to 0. You can factorize them and it provide you minus 1 and minus 2. The complementary function in this case equal to c1 minus 1 power n and c2 minus 2 power n. In this case, you can see that the absolute set is of the both z1 and the z2 is greater than or equal to 1. Therefore, the system is unstable. We can conclude that the system is unstable because the two roots minus 1 and minus 2 are lying outside the unit circle of the set plane. The next one, we determine the particular function of the yp or the force response of the can be determined from the weight sum of the mathematical form and its delay excitation of xn. In this case, xn is 3 or the constant, right? 3. Therefore, we set them yp equal to p constant. We substitute p in this case. The unknown coefficients p of the force response can be determined by you substitute yp into this different equation. Okay, into this different yp in here, and x is set to be 3u. Okay, 3 or 3. 3un or 3. Okay, therefore you can set them to be, okay, 6p equal to this, p equal to 0.5. 0.5. Now you already get the particular solution. The next one, we combine to, we add them together. The general solutions yn can be expressed as the sum of the complementary function yc and particular solutions yp. Okay, here and here. Okay. Okay, the first one yc is here. Okay, yp is 0.5. Now you can see that we have c1 and the c2 as the unknown coefficient, and we can determine them by use the initial condition. We use the first initial conditions when n equal to minus 1, yn equal to 0. Okay, n equal to minus 1, yn equal to 0. You get here. Okay, if n equal to 0, n equal to minus 2, yn equal to 0 again, minus 2. Substitute every n equal to minus 2. You get here. Two equation, two unknown, you can determine c1 and the c2. Okay, in this case, c1 equal to minus 1.5 and c2 equal to 4. Substitute them, you get the general solution form of this equation is here. Yn equal to minus 1.5 minus 1 power n plus 4 minus 1 minus 2 power n plus 0.5 un. This is the general solution. Okay. The objective of this section is, okay, is force you to determine the solution of this different equation. Okay. We have another one's question. Okay, and we give you another 15 minutes and we provide your solution.
อาจารย์คะไม่ได้ยินเสียงค่ะ
Oh, okay. Sorry. Okay. Can you finish this? Okay. I will provide another 2 minutes, okay, before I provide your solution. Can you hear me? Okay.
yes
Okay, another
Yes,
2
ค่ะ
minutes. Okay, another 2 minutes. I will give you another 2 minutes. Okay. Hello, can you hear me?
Yes,ค่ะ
Okay, I will provide you the second solution of the second question. Okay, consider a system with the input and the output related by this equation and determine the same. Determine the natural response, determine whether the system is stable or not, and determine the forced response when the input is here. You can see that in this case, this example, the differential equation is more simple than the previous, but the forced response is a little bit more complicated than the previous because it's not a constant. It will be in the exponential form. Now, we start by the first, okay? The complementary function or the YC or the natural response can be determined from homogeneous equation. Homogeneous equation can determine from the different equation by Q non-y term. In this case, non-y term is only one, is xn is here. You set them to be 0. Okay, the characteristic equation give you z minus 0.7 equal to 0. Therefore, z equal to 0.7. Okay, we have the first order. We have only one term. Yc equal to c1 0.7 power n. Determine whether the system is stable or not. In this case, you can see that the root of the characteristic equation makes that I equal to 0.7 is stable. Therefore, you can conclude that the system is stable because the root is equal to 0.7 and lie inside the unit circle of the set plane. The next one is the particular function or the YP or the forced response can be determined from the weight sum of the mathematical form of xn and its delay excitation that are different in the form of xn. Okay, here E minus n un, okay, the excitation is the same form, okay, it's the same form. Therefore, it will be yp will be E minus n, okay, but multiplied with the constant p, okay. You can see that in this case, the delay excitation E minus n minus 1 is here, okay. It's only minus 1 in that. Therefore, you can grouping them, okay, separate this term to be here and keep them to be here. You can see that you use the time shifting, okay, move one powers, okay, E plus 1 in here outside the bracket. Now you make E minus 1 and E minus 1 will be identical. You can push this term together. Now you can compare the coefficient of them. The coefficient of this term equal to 1. In the right hand side equal to 1. In the left hand equal to here. You can conclude that, okay, this case P equal to, okay, minus 1.1 approximately that, okay. Therefore, you can state that YP equal to minus 1.1 E minus N. Okay. Now, the overall in the general solution of the Yn can be expressed as the sum of the complementary function Yc and a particular solutions Yp. Okay. The complementary is C1 0.7 N and particular solution is equal to minus 1.1 E minus N Un. Okay. In this case, you can see that it still have C1 as the unknown. We substitute, okay, at n equal to minus 1, y minus 1 must equal to 0. Okay. We can determine the unknown constant C can be determined by using the initial condition. Okay. Substitute n equal to minus 1 in here, minus 1 in here. You can get that C, okay, C1 equal to 2.1 approximately. Now, you can state that, okay, C1 equal to here, you can state that Yn equal to 2.1, 0.7 power n minus 1.1 E minus N Un. Okay, this is, okay, provide you as the guideline, okay, and okay, it's all for this. Okay, the next time we will start, okay, we will start the last chapters for this. Okay, I think. Okay. Any question? Okay, next time in the Tuesday, right? Tuesday. Don't forget to remind me about the final exam detail. Okay. See you next time. Good luck.
thank you
ขอบคุณครับ
You're
ขอบคุณค
welcome.
รับ
สวัสดีครับ